Alright, so hopefully you got all those things together. First thing you're going to do is take your 1-inch broomstick and you're going to cut a 2-foot length. So if I didn't mention, you should have like a tape measure or something to measure with, a yardstick. Alright. Get yourself 24 inches of length there and cut it flush. Okay. If you have the top of the broomstick where it's rounded off, that's going to be the top of your pump drill. Alright. Here I don't have that. These are cut flat on both sides. But the rounded part, that could be the top of your pump drill. Next thing you're going to do is, I forgot to mention clamps. You may need clamps. All right. Here I have my quick clamps. And what you're going to do is on your work table, hopefully you have one, you're going to clamp down your broomstick. And you're going to take your 1/2-inch drill bit and you're going to mark down 1/2 inch of the full cut, alright, and mark it with tape so you don't go farther than that. Now these reloads that you have, that you got hopefully, they're only 1.5 inches long, so we can't shove the whole thing inside the reload socket hole of the base end. Alright. Your 1-inch hose clamp, by the way, is 1/2 inch tall. So we only need a 1/2 inch size hole. 1/2 inch in diameter and 1/2 inch in depth. So your 1/2 inch drill bit, we're going to measure down 1/2 inch, mark it off with tape. Okay? So from there, now this is already done. This is secured to your workbench. You're going to measure what the center inside the diameter of your broomstick is, and you're going to drill in, okay, into your broomstick, all right, 1/2 inch. After you've done that, you're going to quarter. You're going to quarter that hole. Okay? I don't know if you could see. I'm going to quarter that down with, I have a bandsaw, so that's how I did that. Otherwise, you'd have to use a handsaw of some sort. Alright, so that's quartered. It's quartered down 1/2 inch. And here we have our 1/2 inch hole. Okay? So inside there is going to fit a dowel pin, all right, fluted dowel pin. So that'll fit right in there. All right, and it should slide in and out fairly easily. There shouldn't be too much room. Your hose clamp, which is 1/2 inch wide, should just cover your quarters that you cut. Okay. Take your screwdriver and you can clamp that down right off the bat. And that's secure in there. That's not going to come out. Okay. Now with your pencil, okay, you're going to measure up from the bottom of the base, not from the reload, but from the base end. You're going to measure 3 inches. 3 inches up, and you're going to make a line that goes all the way around. All right? Make your 3-inch line up from the base. All right. Now, if you don't know, 2x4s are actually 1.5 by 3.5. Okay, so if you have a tape measure and you measure these, they're 3.5 by 1.5. Okay, they're not 2x4. So somebody's making money somewhere. Anyway, since your studs are 1.5 inches wide, you're going to measure another 1.5 inches from that 3. So you have your 3, okay? You go up another 1.5 inches, and you're going to mark that, okay, around. You're going to mark that around. Okay. Mark that around there. And here I have it darkened a little bit to show that this is where my flywheel is going to go. All right. Now from that last mark we just made, okay, 3 inches, now another 1.5 inches, we're going to go up another 2.5 inches. So another 2.5 inches up from that, we're going to make another line. All right. Now if we add all that up, what we have left with from the top to that last line is 17 inches. Okay. So we have 17 inches of length here to this last line. Now you're going to take your pine stud and you're going to mark off 2 1-foot sections. So 12 inches and then another 12 inches. Now if your pine stud has knots, okay, if you have sections that are free of knots and sections that have knots, I would recommend that with the 12-inch, the 1-foot sections you're about to cut off, use the sections that have the knots. Okay, use them up because this is going to be your flywheel. So if you're going to use wood that it needs to be knot free, save that wood. Okay. So let's say we cut our 2 12-inch sections of 2x4. Okay. The next thing we need to do is drill these holes. So you need to find 6 inches on each side and get the center. Then this is 3.5 inches across. So at 1.5 inches and 1 3/4 inches and 1 3/4 inches, you're going to mark the midway point. 1 3/4, 1 3/4. Okay. It's at this point here in the exact middle that you're going to drill your 1-inch hole for your broomstick handle. Hopefully there isn't a knot right there where you're going to drill. Okay. So what I'm going to do is drill these holes right now and then come right back. All right? Okay, so I cut out the 1-inch hole on both of these. Okay, as you can see. Now the next thing you're going to do is, this is going to be our flywheel, but it's going to be one flywheel together. So actually what we're making is one of these, in a sense. Okay, we want something that's kind of round. Now you probably saw the video of the guy doing the stud 2x4, which is only one. But to start off, we're going to get something that's round, and we're going to do a cross. All right, so the next thing we have to do is line up our 1-foot studs, and we're going to put our broomstick handle in there, and we're going to take our pencil and we're going to measure down from the top one. The bottom one, we're going to just go straight across and do 2 lines. Okay? That's where we're going to make our cut. And actually, if we flip this upside down, because we have to do both. Is we're going to make our other cuts there. Okay, because this is going to come together. Alright? And be flush, like this, in a sense. Okay? They're going to lock into each other. So I'm going to cut and remove these sections here halfway down. So we're going to go down 3/4 of an inch. So if your pine stud is 1.5 inches in width, we're going to take out half, and that's 3/4 of an inch. Okay? Alright, so I'm going to do that, and we're going to come back. Alright, so we made our cuts. Alright, now I made mine on the bandsaw. Now, if you have a router, you're all golden. You may be able to get away with this too on a table saw if you're very careful. You could just rip those across and take out any slivers. So the next thing we do is put this together. Okay. Now you may want to, with your pin nails, is put your flywheel together. Make sure the hole is lined up. You need just 4 nails. You could probably do 8. Do 4 on each side. Okay, notice I'm going inside the square. Okay, I'm going to flip it over and do the other side. Now remember, when you're using power tools, to wear your safety goggles, and if necessary, have your gloves on. Alright? You don't see me operating the machinery, you know, on and off, and like that, but you should have your safety gear on. Okay. So we got our flywheel. Hopefully it's nice and balanced. We're about to find out, actually. And your broomstick handle should fit right inside, and it should be a nice, solid fit. Okay. There we go. And we're going to slide that right down to our 1.5 inch slot there. As we make this, we're going to discover if we have anything that's out of balance. I can see the plane is going to be off on this a little bit. Alright. Alright, so the next thing we're going to do is we need to attach this flywheel to our spindle. And so we're going to take our pin nails. You may not have a hole in your table like I do, but it can come in handy. And again, from the bottom, that's where we do our nails, right? So we're going to hammer in our nails to secure our flywheel. use my screwdriver for a nail driver. This side. And we're just going to make our way around. Flywheel looks a little crooked. So that's secure on there. That's not going to go anywhere for now. Now you notice the plane is off. Okay? That if I were to turn it, you see that it has a wobble in it, right? But you always try to avoid that. But if your wheel, if the mass of each side of the wheel is balanced, then your plane should not be too much of an issue, okay? And we're going to see what happens when we try to balance this out and pull this off, all right? So from the top of your broomstick, you're going to carve your knock, okay? I used my bandsaw to put a knock in, only about 1/2 inch down, and that's going to fit our pressure bar brace, okay? Now, what you can do here is take your 2x4, all right, and if you have a table saw, rip your 2x4 in half, and by half I mean where it's not where it's 3.5 inches, but where it's 1.5 inches. If you could rip that directly in half and get yourself 3/4 of an inch and 3/4 of an inch, okay? Try to do that. Now we're 17 inches tall, right? That's our 4. We're doing 3, 4, 5. So we have 17 inches. That means that if we do our 3, then it needs to come out 15 inches to the side. It needs to come out 15, which is right here. 17, 15, and our chord is going to be 19 down one side. So when we double 15, we get 30. So if you have a table saw, or if you happen to have a thinner board, like this piece of pine, that's a 2.5 inch by 3/4 of an inch. You could buy these at the hardware store too. Okay, but you have the 2x4, and if you have a table saw, you can get this done. Measure out 30 inches. Okay, so measure out 30 inches, and then cut that in half down the side, lengthwise, and get yourself a pressure bar brace. All right. So do that first, and then we're going to come back and throw on the bar brace. All right, let's go. All right, so we're back. So hopefully you got yourself your pressure bar brace, okay? Now here's what I did. I already found the center and cut a slightly larger than 1 inch hole in the center there to receive the spindle. Because our broomstick is 1 inch, we need it to be just a hair bigger than 1 inch. Okay? I already cut my nocks on each side to receive our cord. All right, and now we're going to cord and measure the length of the 5 measurements of the 3, 4, 5 on the pump track. So the first thing you do is take your cord and you make a knot on one side, or 2. Let's do 2. That's going to go on one knock there, which fits in there. Okay. Now, get something to hold up your pump drill. All right. We're going to put our pressure bar brace on through the spin. Put the spindle through the pressure bar brace. Now, here's what I want you to do. I want you to measure. I want you to put the bar brace just under the black line, and I do mean under. Okay, we're going to make it so that it is on top of the black line, but here's what I want you to do first. I want you to measure the bar brace where it's the top of it is at the line, so you can see the line. Okay, then I want you to put your cord on the top knock, okay, of your spindle, and then measure out the cord to the other knock. Now again, like I said, I want it so that the line goes to the top of the pressure bar brace, okay? Now once I have that measurement, I'm going to push down on this a little bit. Okay, because there's going to be some give, all right? So when you push down on it a little bit, pull up on your cord. Because there's going to be some stretch. And where it stretches, we want it to be at that line, okay? Because if this stretches, if you measure to the line and this stretches again, you're going to hit your flywheel. We have to make sure this doesn't hit your flywheel. All right. So push it down, pull up on your cord, push down, a little bit more. All right, so that's the measurement we want. Now, I'm going to take my marker, and underneath, I'm going to mark that that's where I have to put my knots. So I take my string off, okay, and I cut my string past where past where I made the mark. All right. Now put your knot below the line you drew. And put it back. Measure again. Okay, that looks good. Now here's what I want you to do. want you line up your triangle on both sides, okay? Make sure it's even. Now I want you to, with your marker, mark your cord on each side of the knock up above, okay? Here. I mean, literally right alongside that knock. Now take it off. Take your cord off, your pressure bar brace, and I want you to make a knot to each side of that line. Okay, so leave the line there, leave those lines there, okay, and you should have a knot on your left side of that line and a knot on the right side of that line, okay? And what that's going to do is hold your spindle in place, the cord on the spindle, so that the bar doesn't ride up and down. Okay, so I have a knot. See, I made my two lines on my cord, and I have a knot on this side of that one, and I'm going to make a knot on this side. This is why I asked you to measure below the black line on the spindle, because we're going to raise the bar up by 2 knots of cord length. Okay. Put the cord back on the knock of your pressure bar brace. Put the pressure bar brace around the spindle. Now, you have 2 knots that are going to fit on each side. You have 2 knots that are going to fit on each side of your knock. See? And now it won't go anywhere. It won't slide around too much. Alright? Okay. Now let's see. Our base is going to be some pine. Alright? Some scrap of pine lumber. That's already been mated. Has a notch in it already. Now when you're doing pump drill, the notch has to face toward you. Okay? It's like the bow drill or the hand drill. Okay, the notch needs to face toward you because you have to look down at it. It can't be on the opposite side like a mouth drill. But in this case, I'm going to put the notch toward you so that you can see a little bit. Alright. I'm going to fill the notch with some sawdust that I have here because it's a little high. Now, these are brand new fluted reloads, so they're going to bind a little bit, but don't let that disturb you. Okay? That's not bad. Now, it's off its plane, as you can see, right? One side is higher than the other, but what matters is that the mass is equal on each side, equally throughout the spin. Now normally I would be looking down at the notch, but I can't because it's on the opposite side. So I'm going to have to kind of gauge how we're doing. Well, it's smoking. So it's warming up. How are we doing? I think we're getting there, so I'm going to keep going. What's nice about the pump drill is that you could go for a long time. So duration isn't so much of a problem because it balances out your energy variable. You have a lot more energy to be able to go longer. You see how important it is to have that clearance above the flywheel? Okay, let's see how we did. Oh, almost. You know what I'm gonna? This started to round off. So let me just cut the spearing off. So we get rid of that dead space center. All right. Let's warm it up again. Now I have no idea what this wood is on the reload. No clue, because it doesn't say. They just don't tell you on the package. So the pump drill is a great way to test the wood if you don't know what it is. It's an unknown wood. How do you know it's going to work without using up all your energy? Because that's really what you should worry about, is are you going to have enough energy to be able to keep going later? And here's what we got. A lot of black, charry stuff. So I'm thinking maybe I need to lighten up on the pressure a little bit and just do more speed. Okay, so I'm gonna put in a new reload and try again. All right, because we're testing this out. Okay, I changed the reload. Again, we have no idea what wood this is that we're using for the reload. All we know is that they are fluted dowel bits that are 1/2 inch in diameter and 1.5 inches long. And we're making them our reloads. So, like I said, I'm going to back off on the pressure and really just go for speed. Now you'll find yourself getting into a rhythm. And again, you have to capture the flywheel as it's on its way back after it's stored energy. Now the other points too about the pump drill is that it's not a bipolar method anymore. It's unipolar, just like the hand drill, okay? So there's nothing bracing the top to keep its axis straight in that sense. You have to do it from the bar brace. The other thing too is the cord wraps around both sides of the spindle. So again, we're back to our bilateral force. So we're away from our unilateral force of the bow. The spindle is being pulled equally from both sides, okay, which is very important to understand. Now the pump drill is kind of a cousin of all the other methods, like an odd cousin, as I call it. And the pump drill too is not meant for hardwoods that require a lot of pressure. Like woods that an Egyptian drill or a crutch drill can pull off, you can't do with a pump drill. With a pump drill, you have to go with woods that you kind of know work. And there's our coal. So I needed to back off on the pressure a little bit. And just keep going. So that balanced things out. So whatever wood this is, it can work. So let's see what else. Oh, so now the reason why they're in this order, hand drill, mouth drill, bow drill, pump drill, toggle drill, again, we're going more pieces, less effort. Now I have plenty of energy. That's the thing about the pump drill, is it doesn't use up a lot of energy. So, and you'll see with the toggle drill next, you're going to have the best of all the worlds. But the only thing a pump drill really lacks is the ability to handle very, very hard woods, because its pressure ability is on the medium scale. All right. So you have to always kind of keep that in mind. Your flywheel, what's very important about your flywheel is its mass must be equal completely on all sides. All right, that's more important than the plane being flat. Now, as you'll notice on my soapstone wheel, the plane on my soapstone wheel, that aside, isn't perfect either. Because when I drilled the hole, it started to drift over to one side. And I'm just going to do this for example's sake. If you look at the top of the flywheel, it's off. But not only is the plane, the horizontal plane of the soapstone flywheel off, the mass is also off, because the way it drilled through the stone, there's a little bit more mass to one side of the flywheel than there is another. And you could probably see the wobble. That really throws off the rhythm and the axis of it, really. So you have to center that as best you can, although this is a functional drill. One of the ways you can fit a flywheel to your spindle is and this requires a lot of carving, is if you carve out your spindle, okay, your spindle should taper. So it gets wider at the bottom, thinner at the top, and if you have a standard hole through your flywheel, when you fit the flywheel down, it comes to a juncture where it just wedges in to the spindle. But that takes a lot of work. So if you have something like a lathe, where you can instantly, make out a spindle just like that, or if you want to take the time to do it, a hand carved project, and eyeball it, that's great. More power to you. All right, but that's another way you could fit your flywheel on there, is that it wedges in on a tapering spindle. Now, if you see the website of the guy in the UK who made a soapstone flywheel pump drill, and it's a real work of art. His spindle is a tapering spindle, and the soapstone sits on there because it's wedged by gravity, okay, on there, just through friction alone. All right. Remember your 3, 4, 5. For math, it's kind of an easy measurement to kind of do and pull off. So, especially once you know where to begin. Start with the 4, get your 3, and the 5 is easy. So whatever that is, and everything just kind of has to be equal after that. So if your 4 is a 10, your 3 is an 8, and your 5 is a 12. So it's very easy to figure out. Just replace one number with going up in an equal measurement. Let's see, what else? That's really about it for now. So let me go over my other 3 for our basic, and then we're going to move on to art of the variation. All right, let's go.